Getting ready for a software developer interview? Not sure what questions to expect? In this video, we cover the top 30 most asked questions, from basics to system design. Whether you're a fresher or an experienced dev, this is your ultimate prep guide. Let's level up your interview game. Now let's start with first section, general software engineering questions.
1. What is software engineering?
Software engineering is a systematic approach to the development, operation, and maintenance of software. It combines principles from engineering and computer science to ensure that software is reliable, scalable, and maintainable. It involves various processes like requirements analysis, design, coding, testing, and maintenance to produce high-quality software. The goal is to manage the complexity of software projects and deliver solutions that meet user needs within specified constraints such as time, cost, and resources.
2. What are the key phases of the software development lifecycle, SDLC?
The software development lifecycle, SDLC, comprises several key phases. 1. Requirement gathering, understanding user needs and constraints. 2. Design, architecting the system and choosing technologies. 3. Implementation, coding and developing the software. 4. Testing, verifying the software for defects and performance. 5. Deployment, releasing the software to the user environment. 6. Maintenance, handling ongoing updates and bug fixes post-deployment.
3. What is a framework in software development?
A software framework is a structured platform for building software applications. It provides reusable libraries, components, and tools that simplify and accelerate development. For example, frameworks like Django, Python, or Spring, Java allow developers to focus on specific features while the framework handles common concerns like security, database access, and URL routing. A framework promotes best practices, reduces the need for repetitive code, and fosters consistency across applications.
Next section is programming languages and concepts. These questions test a candidate's proficiency in specific programming languages and their understanding of core programming concepts like object-oriented programming, functional programming, and memory management. They reveal the candidate's ability to write clean, efficient code in the required language.
4. What programming languages are you proficient in, and which do you prefer?
I am proficient in several programming languages, including JavaScript, Python, Java, and C#. My preferred language depends on the project. For web development, I prefer JavaScript for its versatility and strong community support. For data science and machine learning tasks, I rely on Python because of its vast libraries like NumPy, Pandas, and TensorFlow. For enterprise-level backend systems, I find Java's scalability and performance appealing.
5. What is object-oriented programming, OOP?
Object-oriented programming, OOP, is a programming paradigm based on the concept of objects that contain both data, attributes, and methods, functions. It revolves around 4 key principles. 1. Encapsulation, bundling data with methods that operate on it. 2. Abstraction, hiding complex implementation details. 3. Inheritance, deriving new classes from existing ones. 4. Polymorphism, allowing objects to be treated as instances of their parent class. OOP makes code reusable, scalable, and easier to maintain.
6. What are the differences between statically and dynamically typed languages?
Statically typed languages, e.g., Java, C++, require variable types to be explicitly declared, and type checking happens at compile time. This helps catch errors early but can make code more verbose. Dynamically typed languages, e.g., Python, JavaScript, infer types at runtime, offering flexibility but potentially leading to runtime errors. The choice between the two depends on the project. Static typing provides more safety, while dynamic typing allows faster prototyping.
Next section is software design and architecture. These questions focus on the design principles, patterns, and architecture used to structure software. They assess the candidate's ability to design scalable, maintainable systems and understand how different software components interact.
7. What is the difference between monolithic and microservices architecture?
In a monolithic architecture, the entire application is built as a single unit where all components are tightly coupled. While easier to develop and deploy, it becomes challenging to scale and maintain as the application grows. Microservices architecture, on the other hand, breaks down the application into small, loosely coupled services that communicate over APIs. Each service is independent, making scaling and maintaining easier. It also enables teams to work on different services simultaneously. However, managing multiple services adds complexity to deployment and monitoring.
8. How do you handle scaling a web application?
Scaling a web application involves increasing its capacity to handle more traffic and data. There are two main strategies. 1. Vertical scaling, scaling up, adding more resources, CPU, RAM, to existing servers. 2. Horizontal scaling, scaling out, adding more servers to distribute the load. I often prefer horizontal scaling with load balancers to distribute traffic across multiple instances. Additionally, caching mechanisms like Redis and database sharding help improve performance as the application grows.
Next section is algorithms and data structures. Algorithms and data structures questions test problem-solving abilities and the efficiency of solutions. They assess how well a candidate understands performance optimization, memory usage, and selecting the right structure for a given problem.
9. What is the difference between an array and a linked list?
An array is a contiguous block of memory where elements are indexed, allowing constant time access, O1, by index. However, resizing an array can be expensive. A linked list consists of nodes where each node points to the next one. Insertion and deletion are efficient, O1, but accessing elements requires linear time, On, because nodes must be traversed sequentially. Linked lists are preferred when frequent insertions or deletions are required, whereas arrays are better when fast access by index is needed.
10. Explain the concept of a binary search tree, BST.
A binary search tree, BST, is a data structure where each node has at most two children, left and right. In a BST, the left subtree of a node contains values less than the node's key, while the right subtree contains values greater than the node's key. This structure allows for efficient searching, insertion, and deletion operations, typically in O log n time. BSTs are commonly used for applications that involve dynamic data sets requiring frequent updates and searches.
Next section is software development methodologies. These questions assess knowledge of various software development methodologies, such as Agile, Scrum, or Waterfall. Interviewers use these to evaluate how well a candidate can adapt to different team environments and workflows.
11. What is Agile methodology, and why is it popular?
Agile is a project management approach that emphasizes iterative development, collaboration, and flexibility. Teams deliver small, incremental improvements to a product through short cycles called sprints. Agile's popularity stems from its adaptability to changing requirements, quick feedback loops, and ability to deliver working software frequently. It's particularly effective for software development, where customer needs and market conditions evolve rapidly.
12. What is the difference between Agile and Waterfall methodologies?
Agile is an iterative and flexible approach where the project is broken into smaller sprints and feedback is incorporated continuously. Requirements can evolve throughout the project. Waterfall, by contrast, is a linear and sequential approach where each phase must be completed before moving to the next. Once requirements are defined, they are fixed, making it harder to accommodate changes. Agile is more adaptable, while Waterfall is suited for projects with well-defined requirements.
Next section is database and data management. These questions focus on database design, queries, SQL, NoSQL, and data management strategies. They assess a candidate's ability to store, retrieve, and manage data efficiently, which is critical for back-end roles.
13. What is normalization in databases, and why is it important?
Normalization is the process of organizing a relational database to reduce redundancy and improve data integrity. It involves dividing a database into multiple related tables and defining relationships between them. The main objective of normalization is to eliminate duplicate data, ensure consistency, and make queries more efficient. Without normalization, databases may suffer from anomalies such as redundant data updates or deletion anomalies.
14. What is the difference between SQL and NoSQL databases?
SQL databases are relational and use structured query language (SQL) for defining and manipulating data. They store data in tables with predefined schemas, which are ideal for structured data. Examples include MySQL and PostgreSQL. NoSQL databases are non-relational and store data in various formats such as key-value pairs, documents, or graphs. They're ideal for handling large-scale, unstructured, or semi-structured data. Examples include MongoDB and Cassandra. NoSQL is more flexible but may lack the ACID properties of SQL.
Next section is software testing and debugging. These questions evaluate knowledge of testing frameworks, unit testing, debugging techniques, and test-driven development, TDD. They assess a candidate's attention to detail and ability to identify and fix bugs in code.
15. What is unit testing and why is it important?
Unit testing involves testing individual components or functions of a program in isolation to ensure they work as expected. These tests help catch bugs early in development, leading to more reliable code. Unit tests also serve as documentation, making it easier for other developers to understand the expected behavior of functions. By adopting test-driven development, TDD, developers write unit tests before writing the actual code, improving overall code quality.
16. What is continuous integration (CI)?
Continuous integration (CI) is a practice where developers frequently integrate their code into a shared repository. Each integration is automatically tested to detect errors as early as possible. The goal is to reduce integration problems, ensure that the codebase is always in a deployable state, and foster collaboration among team members. CI tools like Jenkins or GitLab CI automate the testing and deployment process, leading to faster, more reliable releases.
Next section is system design and architecture questions. These questions examine a candidate's ability to design entire systems from scratch, covering scalability, performance, and reliability. They assess big-picture thinking and the candidate's ability to architect large-scale systems.
17. What is microservices architecture, and how does it differ from monolithic architecture?
Microservices architecture breaks down an application into smaller, independent services that communicate via APIs. Each service is self-contained and can be developed, deployed, and scaled independently. This contrasts with a monolithic architecture where the application is built as a single unified system. In a monolithic architecture, all services are tightly coupled, meaning a change in one service might require redeploying the entire system. Microservices, on the other hand, offer greater flexibility, scalability, and resilience, allowing teams to iterate on features without impacting the entire system.
18. How would you design a system for handling high traffic?
To design a system that handles high traffic, it's essential to implement horizontal scaling by distributing traffic across multiple servers or instances. Using a load balancer can efficiently manage incoming requests and direct them to available resources. Caching mechanisms like Redis or Memcached can reduce database load by storing frequently accessed data in memory. Additionally, Employing database replication and sharding can help distribute database queries across multiple servers. Implementing asynchronous processing with message queues and optimizing database queries are other key strategies to handle increased traffic without compromising performance.
Problem solving and debugging. These questions focus on logical thinking and debugging techniques to solve programming issues. They assess a candidate's ability to approach a problem methodically and debug code effectively.
19. How do you approach debugging a production issue under time pressure?
When debugging a production issue under time pressure, I follow a systematic approach. First, I gather all relevant logs and error messages to understand the scope of the issue. I then attempt to replicate the problem in a staging environment. If replication isn't possible, I analyze the affected components, reviewing recent changes or deployments. I prioritize quick fixes, such as rolling back recent changes or restarting services, while formulating a longer-term solution. Throughout the process, I communicate clearly with the team and stakeholders to ensure transparency and prevent escalation.
20. Explain a time you improved the performance of an application.
In one project, our web application's load time was significantly high, causing user frustration. After profiling the application, I identified several bottlenecks in the database queries. I optimized the queries by reducing redundant joins and implementing proper indexing. Additionally, I introduced lazy loading for large datasets to prevent loading unnecessary data upfront. I also added caching for static content. These optimizations led to a 40% improvement in load time and a better overall user experience.
Next section is programming concepts. These questions cover core programming concepts like loops, conditionals, recursion, and error handling. They assess how well a candidate understands programming fundamentals and can apply them.
21. What is the difference between multithreading and multiprocessing?
Multithreading refers to the ability of a CPU or a single process to execute multiple threads concurrently. Threads within the same process share memory space, making communication between threads faster, but also increasing the risk of concurrency issues such as race conditions. Multiprocessing, on the other hand, involves running multiple processes simultaneously. Each process runs in its own memory space, ensuring better fault isolation but requiring inter-process communication (IPC) mechanisms, which can be slower compared to threads. Multiprocessing is more suitable for CPU-bound tasks, while multi-threading is often used for I/O-bound operations.
22. What is the purpose of a design pattern in software development?
Design patterns are established solutions to common software design problems that help developers write maintainable, scalable, and reusable code. These patterns provide a standard approach to solving recurring problems, improving code organization, and reducing technical debt. Some popular design patterns include the singleton, factory, and observer patterns. By leveraging design patterns, teams can improve communication as these patterns offer a shared vocabulary. They also promote best practices and help avoid pitfalls associated with reinventing the wheel when facing standard software design challenges.
Next section is code and best practices. These questions focus on clean code principles, code efficiency, and maintainability. They assess a candidate's commitment to writing code that is easy to read, maintain, and extend over time.
23. How do you ensure the maintainability of your code?
To ensure the maintainability of my code, I adhere to coding standards and best practices such as keeping functions and methods small and focused on a single responsibility. I write self-explanatory code by using meaningful variable and function names, as well as providing comments where necessary. Unit testing is another key practice I follow to ensure that any future changes do not break the functionality. I also advocate for regular code reviews and refactoring to identify potential areas for improvement. Writing clear, concise documentation is crucial to help other developers understand the code.
24. What is version control, and why is it important in software development?
Version control is a system that tracks and manages changes to code over time. It allows multiple developers to collaborate on the same project, keeping track of who made which changes, when, and why. Git is one of the most widely used version control systems. Version control systems enable branching and merging, allowing developers to work on features or bug fixes in isolation before integrating them into the main code base. They also provide an audit trail, helping developers revert to previous versions of the code if something goes wrong, thus ensuring stability and collaboration.
Next section is security and testing. These questions cover software security best practices, such as preventing vulnerabilities and securing data. They assess the candidate's knowledge of protecting applications from cyber threats and implementing secure development practices.
25. What is SQL injection, and how can you prevent it?
SQL injection is a code injection attack where malicious SQL queries are inserted into an application's input fields to manipulate the database. Attackers can use this technique to bypass authentication, extract sensitive data, or even delete entire databases. To prevent SQL injection, developers should use parameterized queries or prepared statements that ensure user inputs are treated as data, not executable code. Input validation and sanitization are also crucial to detect and block potentially malicious inputs. Using ORM frameworks and minimizing database permissions can further reduce the risk of SQL injection.
26. What is unit testing, and why is it important?
Unit testing involves writing tests for individual components or functions of an application to verify that they work as expected. The goal is to test each part in isolation to catch bugs early in the development process. Unit tests act as a safety net, ensuring that future changes or refactors do not break existing functionality. Writing unit tests encourages better code design by promoting modularity and simplicity. Additionally, unit tests improve overall code quality and make it easier to maintain the software as it evolves.
Next section is Cloud and DevOps. Cloud and DevOps questions assess familiarity with cloud platforms, AWS, Azure, and practices like CI/CD, containerization, and automation. Interviewers use these to determine the candidate's ability to deploy, maintain, and scale applications in a cloud environment.
27. What is continuous integration (CI), and how does it benefit a development team?
Continuous integration (CI) is a DevOps practice where developers regularly integrate their code changes into a shared repository. Each integration is automatically tested to catch issues early. CI helps development teams detect and address bugs quickly, reducing the time spent debugging later in the project lifecycle. It also enables faster feedback loops, ensuring that the code remains stable throughout development. CI tools like Jenkins or GitLab CI automate the process, allowing teams to build, test, and deploy code efficiently, leading to shorter release cycles and improved collaboration.
28. How would you deploy an application in the cloud?
To deploy an application in the cloud, I would first select a cloud provider such as AWS, Azure, or Google Cloud. I would configure a virtual machine, VM or container orchestration platform like Kubernetes, depending on the application architecture. Using infrastructure as code, IAC tools such as Terraform or AWS CloudFormation, I would script the environment setup to ensure consistency. Continuous integration and deployment, CI/CD pipelines would be integrated to automate deployments. I'd also configure scaling policies and monitoring tools to ensure that the application is highly available and can scale according to traffic demands.
Next section is soft skills and behavioral questions. These questions assess interpersonal skills, teamwork, communication, and adaptability. They help interviewers gauge how well a candidate will fit within the team and company culture.
29. Describe a time when you worked in a cross-functional team.
In one of my previous projects, I worked closely with the marketing and design teams to build a customer-facing web portal. The marketing team provided insights into customer behavior and user personas, while the design team focused on creating an intuitive user interface. My role as a software developer was to translate the inputs into a functional and scalable system. We used agile methodologies, and regular communication was key. Through daily stand-ups and feedback loops, we aligned on priorities and successfully launched the portal ahead of schedule with positive user feedback.
30. How do you prioritize tasks when you have multiple deadlines?
When I have multiple deadlines, I first assess the urgency and importance of each task. I use tools like the Eisenhower matrix to categorize tasks based on their impact and time sensitivity. I break larger tasks into smaller, manageable chunks and set milestones for each. By communicating with stakeholders, I ensure that I'm aligned with the project's priorities. I also make use of project management tools like Jira to track progress and readjust priorities as needed. Staying organized and focused helps me deliver quality work on time, even when faced with competing deadlines.
And last section is learning and growth. These questions focus on continuous learning, curiosity, and self-improvement. They assess a candidate's openness to new technologies and their ability to keep up with industry changes.
31. How do you stay updated on the latest software development trends?
To stay updated on the latest software development trends, I regularly follow industry blogs, attend webinars, and participate in developer conferences. I also contribute to open source projects, which keeps me engaged with the latest tools and frameworks. Online learning platforms such as Coursera and Udemy help me stay current with new programming languages and technologies. Additionally, I am active in various tech communities where developers share insights, tools, and best practices. Continuous learning is essential in our field, and I make it a priority to stay informed.
32. What is the most challenging technical problem you faced, and how did you solve it?
One of the most challenging problems I faced involved a performance bottleneck in a large-scale e-commerce platform. The system slowed down significantly during peak sales periods. After analyzing the logs and performance metrics, I identified that the database was overloaded with read requests. To solve this, I implemented database replication and distributed the read traffic across multiple replicas.
And that's it. 30 powerful questions that will help you crack your next software developer interview. Which question surprised you the most? Or which one do you want us to explain in more detail? Drop a comment below, we'd love to hear from you. If this video helped you, make sure to like, subscribe, and hit the bell icon for more tech interviews, career tips, and much more. Thanks for watching, and best of luck with your interview.